Today we're doing section 2.7 and we're going to be solving rational polynomial inequalities, which means we're dealing with fractions. So the only difference here is when we have a fraction, you basically need to set the top and the bottom equal to 0 to obtain your two values. Whatever you get from the bottom, which is this one right here, will never be equal to 0. Well, we can never include it, I should say, because you can't divide by 0. So we need to find what that value is, and we need to make sure it is restricted from our answer. So let's go ahead and try one of these. So just like yesterday, the basic concepts are the same, is that I need it equal to 0. So I'm going to subtract 2. So I have x plus 1 over x plus 3 minus a 2 over 1. And I'm sure you all know that I'm about to say you need to get common denominators. So I'm multiplying by an x plus 3, top and bottom. So in the bottom, I know I have an x plus 3. In the numerator, I have x plus 1. And I'm going to distribute this negative 2 into both of them. So it'll become a negative 2x minus 6. So be careful. You take the sign of this, and that's what you're distributing in. Now I'll combine like terms. In the numerator, I'll get negative x minus 5 over x plus 3. So to obtain our two values, I set the top and bottom equal to 0 respectively. So negative x minus 5 equals 0. I would add the 5 over. And then I'll divide by negative 1. So x equals negative 5. Then I'll have x plus 3 equals 0. And I'll subtract that 3. So these are my two values that are going to go on my number line. So here is our nice number line. I have a 0, a negative 3, and a negative 5. And again, I talked about values that can be included versus not included. So our original equation is x plus 1 over an x plus 3 is greater than or equal to 2. So the value of negative 5 is going to be a closed dot because I can get 0 on the top of a fraction, that is fine. And because it's an equal to, it's a closed dot. What I can't use is a negative 3 because that is coming from the denominator of a fraction, and I would get an undefined result. So now I need to test my values. I'm going to test a negative 6, a negative 4, and a 0. So we're going to just get right to it. So negative 6 plus 1 over negative 6 plus 3. So in the top I'll get negative 5 over a negative 3. And I know a negative divided by a negative is a positive, and this will be 1 2/3. And this is not greater than or equal to 2, so this statement is going to be false. So next region we're going to test is negative 4. So I have negative 4 plus 1 over negative 4 plus 3. So I'll get negative 3 in the numerator over negative 1 in the denominator, which is a positive 3. This statement is true. So I shade from negative 5 up until 3. Again, I can't go past the 3 until I test 0 and see if that region works. So now I'm going to test my 0. So I have a 0 plus 1 over 0 plus 3. So I have 1/3, which I know is like a 0.3, which is definitely not greater than or equal to 2. So that statement is false. So to kind of interpret our answer in interval notation, which is the last part of the problem, I start at negative 5, and negative 5 is included. And I go until negative 3, which is not included. So this will be our final answer for this problem. So we're definitely going to do a lot of practice on this tomorrow, dealing with the fractions and whatnot, and then the ultimate goal is to apply this to word problems.